This video delves into the blueprint I made for the jump height based landing sounds of my Unreal shooter game project that implements audio using Wise. This is the player pawn blueprint. You can see in the component window I have Wise AK components for the different sounds required. The main idea is to trace a line between the character and the surface below them to determine the height. The higher the player is from the floor, the bigger and the more detailed the sound when they land. To start with, we need Unreal to capture the moment the character is at the peak of their jump. I tried using the isFalling node, but I didn't get any decent results, so this is a workaround. The moment Z velocity falls beneath 0, which is equivalent to falling, a bool argument opens a gate that allows an event tick to pass through. We only want this to happen once until further notice. This spawns a blank actor at the exact position the character is in at the moment they begin to fall. The position of the blank actor is defined by using a transform node, with data from the character's actor. Once the character lands, the actor is destroyed, and the do once node is reset ready for another jump. We then trace a line between the blank actor and a point 2000 Unreal units under the actor, a distance larger than the maximum fall height. The line will hit any surface under the actor. To make sure the line does not hit the character, we make sure to ignore the character. An array node is required here and would allow for any number of actors to be ignored. We calculate the distance of the line trace and convert the numbers into a vector. To make the numbers easier to crunch in Wise, I clamp the range between 0 and 100, which is the default range of an RTPC in Wise. Once the character lands, an AK event is triggered using the hasLanded node. That event, along with the indicator generated by the line trace, is fed to Wise. In Wise, 3 different random containers will play simultaneously. The sounds in random container 2 are larger and more impactful than 1. Container 3 is more textured and bigger than sound 2. Within each container is a number of variations. Using an RTPC named height, which corresponds to the data from the blueprint, I draw curves into the voice volume of each container. Sound container 1 will play at smaller jumps or falls, 2 at middle and 3 at higher. The curves overlap for a smooth fade between each container, and no dips in volume occur at given numbers.